Hi everyone. So the question we're taking up right now is next greater element, and the thing here is that we want to find the next greater element for every number in the array. So the catch here is that the array is circular, which means that the elements next to the right of my last element would be the element at the leftist part of the array. So, if we don't have a next greater element, we have to return -1. So, we know that we have to return an integer array. So, let's create a next greater element array. Next greater list is equal to new int, and the length would be. So, let's calculate the length and store it in a variable called n. Now, what we do is we have this array with the length n, and in the end, we are going to return next greater list. Now the question says that if we find no next greater element, we have to return -1. So let's fill this array with -1. Sorry, next greater list, and let's fill this with -1. So now we see if this was not circular, for example, how would we approach the next greater element solution? So like let's say if my array is 1, 2, and then 1. So we could go from left to right, fine. So for every element, let's say this is my element, okay, current element. We would scan the remaining elements at the right of it and then check which element is greater. If no element is greater, we would just say, you know, so we need to find the next first greater number, right? So now we'll check the elements at the right one by one until we find the first next greater. Else we'll just store -1. So, but the time complexity here would be big O of n square. So this is not a very valid approach. You see that there is some repetition here. What is the repetition? For 1, we'll check 2 and 1. For 2, we'll check 1. So, if we somehow go from right to left, we will already have a history, so we wouldn't need to check every element. So what happens? Let's say if my array is 1 2 1 5 4. So when we start at 4, we see there's no next greater element. So we just store -1. And then for 5, we already know that we have seen 4 so far, and 4 was the maximum. But 4 is not greater than 5. So again, -1, then we store 5 in the history. Then again, when we reach 1, we see that in our history, 5 is greater than 1. So then we'll store 5. And in the history, we'll just add 1. So it's basically maintaining history. But the catch here is that my element for, my 4 has next greater element is -1. But this is a circular array, which means after 4, we have 1, 2, 1, 5, and 4 again. So if we somehow knew the next, we just have the copy of this array again, correct? So instead of having this exactly same thing, we can have a virtual array. I mean, since the elements are repeated, right? So we can just may have a history, store the elements to the right of the last number, and then calculate the next greater number. So that would be easier. So we're using our stack here, since we need to know that the next greater element is the last greater element seen. So we need a stack for that. Last in, first out. So we'll have stack of integer. Stack is equal to new stack. Now what happens is we need to double the array, right? So we'll start from right to left. Remember, for int I equal to 2 into n. So what's my, if like, let's say the size is 2n. So my last index is 2 into n minus 1, correct? I is greater than equal to 0, I minus minus. So this is how my loop starts. Now what I need to do is I need to get the current number. So my current number is my name of array is nums. So nums I mod n, correct? So I mod n, why? Because 2 into n minus 1 mod 2 will get what? 1, right? So that's why. So now if we see while what happens if my stack is not empty. Okay. And if my stack is not empty, let's say it has elements. And what do we do? And stack, let's say this is my current number. So if my current number is greater than stack dot peak, greater than equal to stack dot peak, or let's say it's just greater than, what do we do? If let's say my stack is not empty, let's say my stack is empty, we simply add the current number to the stack, correct? I'll just rewrite this thing later. So here what we do, if like let's say my I is less than n, it means we need to compute the result. So my result of I would be, we'll first check if stack is empty. If it is empty, we know that the result has to be -1. Else we just say stack dot peak. This is my result, correct? Now, what do? We push that element into the stack. So now stack dot push current number, right? And now I need to know the history. So what is my history? No, hold. My next greater element C. So like let's say my history has smaller elements. So my stack dot peak is smaller. So my stack dot peak is smaller than the current number. So then what happens? It needs to be popped. So now we do stack dot pop. Fine. And yeah, this is the thing we do. And in the end, we're just returning the next data list. So let's run. Result of my name of array is this. Okay, we are getting a wrong answer. We want 2 to 1, but we are getting 2 and -1 and 2. So for 2, we are getting -1, but it should have been 2. Yeah, so submitting the code. So the time complexity is, see, this loop will run for 2n times. And basically we see we have a while loop here. But the time complexity is not quadratic. Why? Because any element can be added to the stack at most 2n times, where n is the length of the list. And it can be popped at max 2n times, any number. So the complexity is linear, time complexity. What about space complexity? My space complexity is also linear. If I just ignore, the a size required by this next creator list result array, then we have a stack which can at max hold n numbers if everything is sorted in descending order. So time and space complexity is linear. So that was it from my end. Thanks for watching. Bye.